Hey guys, it's Miss Carter again. I am going to explain your notes on exponential rules that were uploaded today to the classroom. So I'm just going to do the examples that were in your notebook on whiteboard so that you can see what I meant, because I know sometimes when you guys copy down these notes, if you're not seeing me do it in real time, it doesn't make sense. So I just wanted to show you the examples that are in your notebook done out for you. So the first one is multiplication. So the example in your notebook shows you 3x squared y1 This is your example. Oh, that's terrible. A little bit better. So in this example, your notes told you to multiply your coefficients. So you would do 3 times 2, which gives you 6. And then it says to add your exponents up. So 2 plus 3 is 5. 1 plus 4 is 5 as well. And this was the answer you got. This is your shortcut, and the reason we do this is because we know that parentheses represent multiplication. So 3 times 2 is 6. Or 3 2 times is 6. But if we know that x squared is x times x, and x to the third is x times x times x, how many x's do we see here? 1, 2, 3, 4, 5. 5 x's. So this is x to the fifth, because it is x multiplied by itself 5 times. So we can just add those exponents up and it will work every time. 2 plus 3 is 5, 4 plus 1 is 5. So that's how we got the answer, and that's why we add the exponents when we multiply. Now for division, I want to give you an example that is similar to what we had already done in class whenever we were factoring. So I would have given you an expression like this and said, what is the greatest common factor that can go into both of those terms? 2 can go into 4 and 2. That's the biggest number you can put into 2 and 4. And the biggest number of x's you can pull from both of these would be 2, right? This has 2 x's, this has 4 x's. So the most I can pull from both would be 2. So we put out front our greatest common factor, and then we put what was left in here. What we were essentially doing was dividing. That's what we were doing. And we put that greatest common factor out front, and then we had what was left over in the parentheses. So if we were to divide, we subtracted our exponents. So 4x to the fourth divided by 2x to the second becomes 2x to the second, because we subtract our exponents. And then 2x squared divided by 2x squared is just 1. Right? See how that makes sense? And I can give you a simpler one. Well, not simpler, just a different one. Let's say we have 3x to the 8th plus 4y to the second over 3x to the fourth plus 2y. Let's say this was our example, and I said, I want you to divide this. Your answer would be 3 divided by 3 is just 1. X to the 8th minus x to the 4th is 4. Right? 8 minus 4 is 4. And then 4 divided by 2 is 2. And 2 minus 1 is 1. Right? So it would just be this when you simplify it. 3 divided by 3 is just 1. 4 divided by 2 is 2. You can put it over 1, but we typically don't do that. So this exponent minus this exponent gives you the other exponent. 8 minus 4 is 4. 2 minus 1 is 1. And again, we don't usually show our 1s as our exponent. 3 divided by 3 is 1. We typically don't show that. 4 divided by 2 is 2. You could put over 1, but we're not going to do that. So when you're dividing, you simply subtract your exponents. Now let's look at a power raised to a power. In your notes it says raise the coefficient to the outside power and then multiply your exponents. So this coefficient of 2 would get raised to the 4th power, which is 2 times 2 times 2 times 2, which we know is 16. And then x to the 3rd is really that, right? But we need to raise x to the 3rd to the 4th power, which means we will multiply this base number 4 times. So x to the 3rd is our base number that gets multiplied 4 times. We do x to the 3rd 4 times. And how many x's is that? That's actually 12 x's. So our answer would be 16x to the 12th power. The shortcut that your notes tell you to do is to multiply the exponents together. 3 times 4 is 12. And that is why we do that. And that is why it is true, and that's why it makes sense. So you just multiply the coefficient to the outside exponent, and you multiply the two exponents together for your variables. Alright, the last one was negative exponents, which can be very intimidating. A negative exponent simply flips your base number in order to turn it into a normal exponent. So if you have a negative exponent and you want to get rid of it and you want to turn it into a normal exponent that you can then use, flip your base number. Your notes say, flip your base number to make your exponent positive. If your base number is a whole number, remember there's an imaginary 1 underneath it. So for this 2, there is an imaginary 1 under every whole number. We could divide every whole number by 1, but it wouldn't change the whole number. So I would flip this, and then my exponent would become normal. So this would be 2, this would flip to 1 over 2 to the 1st power. So when you flip it, your exponent isn't negative anymore. You can make it normal, so it would just be 1/2. If your base number happens to be a fraction, you're still going to flip it, so it would then become 2 over 1 to the 1st power, which we know 2 over 1 is just 2. So your answer is 2. So anytime you have a negative exponent, you simply flip your base number. Now the example that was given to you in your notebook has a bunch of letters and some numbers. It's 2a to the 3rd b over 9c to the 5th d to the negative 5th. Now there's nothing I can simplify. 2 divided by 9 can't simplify down any further. I can't subtract my a's because there's only 1. I can't subtract my b's because there's only 1. I can't subtract my c's or my d's. They don't have any other like terms to subtract with. So this, being our only one that has a negative exponent, can flip up to here and then become positive. So in your notes, you'll see that d to the negative 5th moved up and became d to the 5th. So you can flip it to the other side of the fraction and make your exponent normal and not negative any longer.